Alright, so today I will be solving number 15 out of the textbook, and as you can see here, it says complete the truth table below to determine whether the negation of P and not Q is the negation of P then Q. So just to set the stone and highlight a few details to get started, I wrote down here that the truth table is essentially a diagram that's used to show possible true and false patterns for a statement. So then getting into our rules for our truth tables. So first off, I have our conjunction right here, and as you can see there, I highlighted that those are end statements. So P and Q. So right here, I listed the possible outcomes for both P and Q, and here is the solution to them. So if P and Q both have to be true, as you can see here, if P is true, Q is true, then P and Q is true. On the contrary, if P is false, Q is false, those aren't true, so P and Q would be false in that case. And then we have our disjunctions, or statements. So in this case, at least one of them has to be true. So as you can see here, P is true, Q is true, so P or Q is true. But here you have, if P is false, Q is true, P or Q is still going to be true because one of them is true at least. And then moving on to our conditionals. So these are if-then statements. So same thing goes. You write down your possible solutions for both P and Q. So if P is true, Q is true. Then if P, then Q. So if P is true, then Q is true. So we have that right here. And then one of the trickiest things to remember is right here. So this statement, it's kind of like, as an example we learned in class, if Steve eats his broccoli, then Steve will get dessert. So here is our only false statement right here. So we really have to remember that when we're working with truth tables. Okay, so now that we went through the rules for our conditionals, disjunctions, and conjunctions, we will probably have an easier time working on our truth table, so I will leave that right there. So we are going to start from left to right. So our end goal is to get all the way over here so we can solve our question. So we're going to start with our P and Q columns. So remember up here, we put in the possible solutions for both P and Q. So here we are going to put true, true. Second we have true, false, false, true, false, false. So in this column, we have negation of Q. So keep in mind the negation is always the complete opposite. So if it's the negation of Q, and Q's right here, say we have a true right here, the negation of true is obviously false, right? So we put false in that column. For this one, if Q is false, then the negation will be true. And continuing down the line. So then going on to our next column, we have P and not Q. So just as we learned in this column, the negation of Q is the exact opposite of what Q would be. So P and not Q. So we look at the P column and then the negation of Q column right here. So we have a true and a false. So in this column, we would have a false statement right there. So we go down here. P is true. The negation of Q is true. So that would be true. False, false, and that's false. P is false, negation of Q is true. Right there, we have another false statement. So in this column, we only have one true statement, and that is P is true, and the negation of Q is true, right there. So moving on to our next column there, then we're almost done. So it might look harder than it is, but actually the way I see it is This is essentially the same thing as this column, yet everything is negated. So, just as we learned before with Q and the negation of Q, essentially the same thing. So in this column, since P and the negation of Q, or P and not Q, is false, this would be true, this would be false, true, and true. So just going back there. So basically, I lost my pen there. Basically, the same thing as this column, we just have the negation. So we flip everything around. Seems pretty hard when you look at it at first, but then going back and looking back at our other columns, we can figure it out. So now we have P then Q. So if P then Q, so that is going back to our conditional statement. So if we can remember from our rules, P and then Q. P if P then Q. So going back to our rules here, so P is true, Q is true. So we are going to have a true statement here. And then remember the tricky part of this statement. So P, true, Q, false. And this goes back to our example of Steve eats his broccoli, Steve will get dessert. So remember, this is our only false statement in our if-then statement. See, as we go back to that, our conditional right there. So then we have false and true. So that is true. And false would also be true for that column. So we are getting there. So right here, we have in parentheses, if P then Q, and everything is negated. So remember, when we negate something, we totally flip it around, and it's the exact opposite as we've done in our other columns. So right here, if P then Q, if that's true, it's obviously going to be false. If this is false, it is true, false, and this is also false. So after we finish our truth table, we can finally go back to our original question and determine whether or not it is true. All right, so going back to our question, it says complete the truth table to determine whether the negation of P and not Q is the negation of P then Q. All right, so going back to our table, our truth table here. So what we want to do is we want to look at both this column and our last column here. So just as the statement up here states, so this would be our negation of P and not Q right here. So we have our sign right here. So we look at this column and this column, and we want to see if those add up. So right here we have a true statement, false. Keep going, false, true. So as you can see, none of those add up. So because of that, we can determine that the negation of P and not Q is not the negation of P then Q. So how we write that, this is going to be negation, parentheses, P and not Q is not equal the negation, parentheses, P then Q. So that is our final answer, and by drawing our truth table, we could reach that conclusion right here by looking at both this column and this column right here. And in order to do that, we had to solve the rest of these to get to that stepping stone point right there.